In this tutorial, I will demonstrate how to construct stem and leaf plots within Excel. Now let's talk first of all about the basic idea or the logic behind a stem and leaf plot. We can take a quantitative variable, and if we so choose, we can graphically represent the distribution of that quantitative variable for a sample by using a histogram, for instance. Now, one problem with using a histogram, however, we use bars to represent the frequency of certain bins or certain groups of values typically within our quantitative variable, and in so doing we lose some of the specificity. For example, we might have a bin such as we have data here for pulse for a group of individuals in beats per minute that would contain the values of 70 up through to 79. There may be another bar or a bin that then would contain the values 80 through 89 and so on. When we do that, we know then we can identify how many individuals fall into the 70 to 79 beats per minute bin, but we don't know what values those individuals actually take. In that case, a stem and leaf plot will provide us more information than a histogram, but still allows us to provide then the general graphic shape or picture of what the distribution looks like for a given quantitative variable. The logic underlying then of constructing a stem and leaf plot is we need to then divide our quantitative numbers that we're using that comprise our variable for constructing the stem and leaf plot. To do so, then we can take any given number and we can break it up in terms of its numbers places. And in this case, using pulse beats per minute, such as we have here, we can see the very first case that we have in our sample has that individual has a pulse of 76 beats per minute. We can break that up into hundreds, tens, and ones. 0 hundreds, there are no hundreds here for this value of 76. It is comprised of 7 tens and 6 ones. The case number 2 then is comprised of 8 tens and 8 ones. A pulse of 72 is comprised of 7 tens and 2 ones. A pulse for case number 4 comprised of 5 tens and 6 ones for a pulse of 56. And we can do this for all of our different values here. If we look, for example, at case number 14, a person who has a pulse of 104 beats per minute, that can be broken down in terms of its numbers places as 100, 0, tens, and 4 ones. Individual number 15, case number 15, at pulse of 88, that pulse can be broken down into 8 tens and 8 ones, and of course 0 hundreds. We can do the same thing then for case number 16, a person who has a pulse of 124 beats per minute, and that's an individual whose pulse then has value has 100, 2 tens, and 4 ones. So we can then break down all of our values here that we see within our data, within our variable for pulse, according to its individual numbers places. Now, the way in which we break then each of our numbers down into stems and leaves, it implies here then that we have 2 parts that will break each number down into. We typically will look at the numbers place that is to the left, or the highest numbers place within our data. Now, if we scroll down through all of our data, we would see that there are only a couple of cases that have numbers of 100, and the rest then are below 100, which would then have 0 hundreds. Now, if we use that as our stem, we would only have 2 bins in essence, 0 hundreds and 1 hundreds. Well, that's not enough of categories to really demonstrate the spread that we see here within our data. In that case, to construct our stems then, what we'll do, the very left-hand portion of our number then will be defined as the stem, and it's now going to take the 2 numbers places to the right, that being the hundreds and the tens. And you'll see here now we can go from 5, 6, 7, 8, 9, 10, 11, 12, and now we have 8 different bins at least, given what we see right here. So that then will be how we'll go about determining what are the values of the stem for a variable. The leaves then will be what is left over, or what is the numbers place to the right of the stem that we have here. And in that case, if our stems are the hundreds and tens combined, from 5 up to 12, what we would then do for each one of our bins, since we'll have a 5 for one bin, a 6 for a bin, a 7 for a bin, all the way up through to 12 for a single bin on its own, we would find then that the ones could be anywhere from 0 to 9 for any one of our bins. So in this case then, that numbers place to the left, rather to the right, of our stems will comprise the leaves. And for each one of our stems, we can have upwards of 10 different leaves. So a stem of 5 could then have the leaves anywhere from 0 up through to 9. And that's how we'll go about then aggregating or grouping together our different values, but also then reporting those values graphically so we can see the distribution as well as details about the numbers for the quantitative variable we're graphing by using a stem and leaf plot. So now let's demonstrate the process that we'll use to construct a stem and leaf plot. What we have here then, as I showed you in just the previous portion of this tutorial, are data for a number of cases, individuals. We have the information related to the sex of each individual as well as their pulse and beats per minute. If we scroll down to see the range of data we have, it goes down to case number 80. So we have 80 different cases here. Now the first thing that we'll need to do is to identify or get a sense as to what the range of values we have to plot in our stem and leaf plot. And I'll do that first of all by finding the minimum value and also the maximum value for our quantitative variable to plot. To find the minimum value, we're going to use the min function. So equal to begin our formula, min, left paren, and now what I'm going to do is highlight the data range that my data are in, right paren, hit enter, and we see the lowest value is 56 beats per minute. Let's use a similar process, but this time we'll use the max function to find the range of values we have here, in terms of the maximum value of that range rather. And we see the highest is 124. So this tells us then that our bins will be defined first of all by the stems as 5, 6, 7, 8, all the way up through to the value of 12. So now let's go over here off to the right of where the data are, and let's start to construct then the stem and leaf plot. I'll just use the label stems, and I'm going to start with the first stem of 5, the next one 6, 7, and I'll to continue the series down to a value of 12. Now we also then will identify the leaves will be comprised of information in the next cell. Now one of the things that you tend to see is that when stems are defined, let's first of all just make this so that it is centered information, and then typically a line is printed or placed between the stems and the leaves. So I'm going to highlight then my range of values or cells where I have my stems, right mouse click to bring up options, come down and choose format cells, and I want to click on the border tab. The default is a thin solid line. I'm going to use a little bit thicker solid line, and I want this line to be placed then on the right hand border of each one of my cells that contains the stem. Click OK, and right there we have then, as I move this away, we can see what the stems are, values of 5, 6, 7, 8, 9, 10, 11, and 12, and also we can notice then that the column to the right of those stems of that solid line will be where the leaves are. So let's now begin then to enter the formula that we'll use in order to identify the leaves. So let's first of all move the cursor and click to make active the cell under the leaves column to the right of the stem 5. And what we're going to do is use a couple of functions together. First of all, we'll use the repeat function, equal rept, and what I'll do then is left parenthesis. I will then type in the number 0. I'm going to repeat the number 0. Now, how many times do I repeat the number 0? I'm going to type then the comma, and after the comma, I indicate the number of times that a 0 appears here. That is, there's a 5 0 within the sample. Now, the formula for this is going to be a little bit complicated, but let's just go through it. I will use the COUNTIF function, and I will count those values. And let's first of all identify the data range that we are using here. So I'm clicking and dragging all the way down to the very last value in my data range. And you see those are values C2 through C81. Now what I'll do is, in order to define the criterion I'll use in this particular case, I need to, and I put a comma here right after the data range. Now I define my criterion. I'm going to click on the stem for 5, and I'm going to multiply that number by 10. So you notice I didn't type 5 in, I put in F5, and that's the location where the stem 5 is. I multiply that by 10, which now it means then it's a value of 50, and I will add to that a value of 0. I could have just ignored the 0, but we'll show all the information we have here then as we go through this process. And then what I'll do is write paren to close the COUNTIF function, and then another parentheses to complete the repeat function. Now what I'm going to do now is hit enter, and what you notice here, nothing appears. It looks like the formula didn't do its job. Well, actually what it did do its job, in that if you recall a moment ago, the lowest value that we have here within our data range, I believe, is a value of 56. So in that case, we'll find then there are no values of 50. But let's go ahead and expand this. In addition to a value of 0, we also would want to include or report any cases here that had a value of 1 for a leaf but a 5 for a stem. So what I'll do here is move my cursor back up to where the formula bar is. I'm going to now type in ampersand, and now I will continue the exact same formula, typing it in, and it's going to be rept, open parenthesis, and in this case I'm going to put in the value that we see here of 1. I want to report a 1, comma. Now how many times? I'll use the COUNTIF function again, open that up with a left parenthesis, type in my data range of C2 to C81, the same that we saw before, comma, let's define the criterion in this case. Again, it's going to be F5 that we see here, so I'll just type in F5. Again, multiplying this by 10, because the 5 for a stem refers to the tens numbers place. And now I'm going to add a 1 to that. Close my COUNTIF function, parentheses, close the repeat function, parentheses, and what we would then see once we hit enter, if any case had a 51, that would now see that would be reported here as a leaf of 1. If there are 3 cases that have a 51, then 3 ones would be reported for 3 leaves for each of those cases. Hit enter. Now again, nothing is displayed because again we don't have any values here that are 51 in our data. But let me go back, and what I'm going to do is change my data ranges to be a fixed reference from a relative reference. And so what I'll do is just put a $ in front of the row numbers for where the data are contained. And what I'll do with this then will allow me to copy and paste and not have to go back and type that information in again each time. So let's now copy then the part of the formula that goes from and, the ampersand, to the end. Whoops. Copy. And now I will paste it to the end here. And it looks like it deleted what was there before, but actually what we see is that if I click here in this down arrow, it will open up then our formula bar to more than one row. And what we notice now is repeat 1, count if, C2 through C81, comma, F5, which is 5 times 10 plus 1. Well, that's what we had just beforehand. But now what we want to do is to report a 2, and the number of 2's we report will be the number of times there's a 52 here. And how do we define a 52 for a criterion? Well, it's F5, which is going to be the stem of 5, times 10, plus 2. Again, there are no 2's here. But let's now go ahead and let's add in an ampersand after that. And you see what we're going to do. We're going to identify then and expand this so there's a separate repeat function is used for each one of the leaves from 0 up through 9. And so I'm going to now copy. So I just highlighted everything after the equal sign with your cursor over top of what was highlighted. Click on the right mouse button, choose copy, and now I will put it at the very end here. Now I'm going to go, we started with 0, 1, and 2 for the leaf, the different leaves. I want to now add 3, which means I have to make it 10 plus 3. The next leaf will be 4. I have to add a 4 to the 10 as opposed to a 1. The next will be 5, which now I have to add a 5 to that. Now I have 6, 7, 8, 9. So I have 4 more leaves than I have to add here. So let's go back now, and I will also then paste that. I will go back and find 0, what's that, ampersand, 0, 1, 2, 3, and that should give me 4 more leaves I can define here. So I'll just copy that portion of the formula so far. Click to move the cursor to the end of this formula, and now I'm going to do a paste. And what I'll do here, you'll see, we ended up with 5. Now I'm going to start, this next one will be 6. Will be reported every time there is a 56. We will now change this, it will repeat a 7 every time there is a 57. It will repeat 8 the number of times that there are 58s in the data. And it will repeat 9s the number of times there are 9s in the data. Now let's hit enter, and you notice we have 1, 2, 3, 4, 5, 6 different 6's. That indicates then that there were 6 different people in this sample who have pulses of 56, but there's no one who has a 50, 51, 52, 53, 54, 55, 57, 58, and 59 for a pulse. Another thing I want to point out here then is you notice the order which I've defined the leaves. 0, 1, 2, 3, 4, and then lastly 9. That will then, when it reports the leaves, will put all the 0's first, then the 1's first for leaves, and then the 2's next for leaves, and then the 3's next for leaves, all the way up through that the last leaves will have will be the 9's. Okay, and so that's how we go about constructing the formula. Now let's go ahead, and since I've used, in this case, the fixed reference for the data range, and I've also defined the stems by what we see here, by what's reported in the cells. I use cell references, not the values of the stems. Let me go ahead and copy that formula, and I should be able to just paste it in the remaining cells for the leaves. And that's what I've done here, and you notice it automatically now then goes out and finds then the values from 60 through 69, 70 through 79, 80 through 89, and all the way up. So we see here then there is one case that has a value of 124, one case a value of 104. We then see a case of 96, a second case of 96. So each leaf then indicates that this is the units or the ones numbers place for a given case within the data. And there we see a very general outline of the shape of our distribution for our quantitative variable. Now let's go ahead and add a key, and we'll put the key down below our stem and leaf plot. And for that key, what you tend to see then, and what we'll do is I like to use the very first value that is reported here, and you see that with a stem of 5 and a leaf of 6, the first value is 56. So I'll type in a 5 space, and then I'll put in a line space and a 6, and then equal 56. So that way someone knows how they should go about then interpreting the information that we have up here. What I can also then do, let's go ahead and widen the column that the leaves are in, so that way it contains then the longest list of leaves we have here then associated with the stem 6. I can go up here and let's add in a title for this, and what I can do then is highlight those two cells, format cells, and what I'm going to do now is click on a line and merge them. And let's put in here now figure stem. I'll put in, how about pulse? And I'll put in parentheses beats per minute. Stem and leaf plot. And the reason why I went ahead and merged those two cells together, now I can just click on it, the title, and I'll click center, and it centers it over the actual stem and leaf plot itself. We can also bold then that title, and what we can also do in addition to that, I like to have a narrow column before and after any of my plots here I'm creating, and I'll put 0.75 for the width of that column before and 0.75 for the width of the column afterwards. Oops, what did I do wrong here? Column width, that should be 0.75, not comma 75. And if you want to, we can even go ahead and let's like to use we'll scroll down here, and I'll use the book Antigua, and I can even change the font size if I wish, but that's fine for now. And I also then will go ahead and bold what we have right here. And let's go ahead and center those two labels, the stems and the leaves as such. And right there we have then our stem and leaf plot. Oops, I see now that by changing the font, what I've done then is I've actually ended up making that the values will take up a little bit more space, so I've just increased then that column so that the entire list of leaves then for the longest list is included there, is contained within the cell. And now at this point, once you're finished with your formatting of your stem and leaf plot, we're pretty much all set. And one of the things I always recommend folks do that when they want to copy and paste this into, let's say, a Word document, if we just copy, highlight the range of cells, and copy that, it's going to also paste the grid lines that we have here that are turned on in Excel. So if you go up under the View tab, open up that menu, and click off the grid lines for this sheet, you notice those grid lines now go. And then we can go ahead and highlight the range of cells, including the thin column before and after, just to give it a little more space when we go ahead and paste it in, say, a Word document. And now when we copy and paste this into Word, we'll see then that we won't have any of those grid lines. So this is how we go about constructing a basic stem and leaf plot.